Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi there, Herman and Corn. So we talked about the RAM apocalypse and some tips for those who are open to the idea of buying secondhand technology components from data centers. Commonly recommended as a thrifty purchasing strategy and commonly recommended as a way for tech enthusiasts and home labbers to pick up industrial grade or data center grade tech supplies, the really good stuff, at prices that aren't going to bankrupt you. And it brings me, Herman and Corn, to ask a question about some of the stuff we see in data centers that is truly data center grade, some of the components. And I asked ChatGPT for some examples of what we're talking about when we're talking about this specific type of technology. And it's actually perfect because it starts off with server grade GPUs, which is something that I've always wondered about. So this name comes up a lot, Intel Xeon, and you don't see many consumer grade CPU. You know, it's just not a name you come across. We talk about i7 and i9 and the i series, but the Xeon has been the workhorse for servers and for workstations for some time, and is relatively less known in consumer world. So Herman and Corn, let's talk about some of the data center grade hardware that might actually be useful in a home server. Other things, multi-socket motherboards, dual or quad CPU sockets. That's cool. Didn't know those existed. NUMA topologies, and then it talks about in RAM, ECC memory. Very common in servers and enterprise workstations and storage systems. I know what ECC is, but I didn't know there's a type of RAM that actually has it built in. Massive RAM capacity, enterprise SSDs, and it mentions in this SAS, which you'll see some talk about in the Data Hoarder subreddit, SAS drives, which people seem to agree is superior to SATA. Hardware RAID controllers makes sense. And then in networking hardware, wow, I didn't even know that NICs go up this much. 100 GBE, 100 gigabit Ethernet. That makes my 2.5 connection seem very slow. InfiniBand, high performance computing clusters. And it goes on and on. So Herman and Corn, what exactly, from this interesting list of specialty hardware, very high end hardware seen in data centers, from these Xeon CPUs through to these super fast NICs, what are some of the things that you might think are most practical for use in consumer, small business, and home lab type environments?
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I am joined as always by my brother, the man who probably has more thermal paste under his fingernails than actual soap.
That is a very specific and slightly concerning accusation, Corn, but probably accurate. Herman Poppleberry at your service. Today we are diving back into the world of hardware. Our housemate Daniel sent us a follow-up to our recent discussion about the RAM-ocalypse. He is looking at this massive list of data center grade hardware and wondering what is actually worth bringing into a home or small business environment.
It is a tempting world, right? You look on eBay or these liquidator sites and you see these Xeon processors that originally cost $5,000 now selling for the price of a nice lunch. Or networking cards that can move data faster than your brain can process a thought. But as we often say, just because it is cheap and powerful does not mean it is practical.
Exactly. There is a huge difference between what works in a climate-controlled, soundproof data center with a dedicated power substation and what works in the corner of your home office or a small business closet. Daniel mentioned a few specific categories: Xeon CPUs, multi-socket motherboards, error correction code memory, enterprise SSDs, and high-speed networking. Each of these has a different value proposition for the enthusiast.
Let us start with the heart of it. The CPUs and those massive motherboards. Daniel mentioned Intel Xeon specifically, and those dual or even quad socket boards. To someone coming from the consumer world where a single i9 is the pinnacle, seeing 2 or 4 CPUs on one board looks like God mode. But what is the catch, Herman?
The catch is usually efficiency and single-core clock speeds. Data center CPUs are built for throughput, not necessarily bursty, high-speed tasks like gaming or photo editing. If you are looking at older Xeons, like the scalable first or second generation chips which are flooding the market right now, you are getting a lot of cores, but each individual core is significantly slower than what you would find in a modern mid-range Ryzen or Core i5.
Right. So if you were running a single-threaded application, that $5,000 server chip might actually perform worse than a $300 consumer chip from this year.
Much worse in some cases. However, where the Xeon shines, and why Daniel might be interested, is the platform features. Consumer chips are usually limited in terms of PCI Express lanes. You might get 20 or 24 lanes. A Xeon scalable system might give you 48, 64, or even 80 lanes depending on the generation. If you want to plug in 4 graphics cards for AI local LLM work, or 10 NVMe drives, or high-speed networking, a consumer board just runs out of lanes.
And then there is the multi-socket aspect. Daniel mentioned dual or quad socket boards. That brings in something called NUMA, or non-uniform memory access. This is where things get complicated for the average user, right?
It really does. In a dual socket system, each CPU has its own dedicated memory banks. If CPU A needs to access data that is sitting in a memory stick attached to CPU B, it has to go across a bus called the Ultra Path Interconnect, or UPI. This adds latency. For a lot of consumer software, even Windows 11, this can cause weird stutters or performance drops if the software is not NUMA aware.
So for a home lapper, a dual socket board is great if you're running a hypervisor like Proxmox or ESXi, where you can pin specific virtual machines to specific CPUs and their local memory. But for a high-end workstation, maybe less so.
Precisely. If you are building a home server to run 30 different Docker containers, dual Xeons are amazing because you can just throw cores at the problem. But if you are trying to build the ultimate video editing rig, you might find that the complexity of the multi-socket architecture actually gets in your way. Plus, those boards are usually in the eATX or even larger proprietary formats. They do not fit in standard cases. You end up needing a rack mount chassis, which means loud, high RPM fans.
Which leads us to the noise and power. People forget that servers are designed to be loud. They do not care about decibels. They care about static air pressure. If you put a dual Xeon board in your office, it sounds like a vacuum cleaner is running 24/7.
And the power bill. Those older Xeons might be cheap to buy, but a dual socket system can idle at 150 or even 200 watts. A modern consumer PC idles at maybe 30 or 40. Over a year of 24/7 operation, that cheap server might cost you an extra $300 in electricity. It is the classic trap of the free car that gets 8 miles to the gallon.
Okay, so CPUs and motherboards are a maybe, depending on your core count needs and tolerance for noise. What about the memory? Daniel mentioned ECC, or error correction code memory. This feels like one of those things that sounds like a no-brainer. Who does not want their memory to correct errors?
This is actually one of the most practical things on his list for home labbers and small businesses. ECC memory is designed to detect and fix single-bit errors. These errors happen more often than you think, often caused by cosmic rays or just electrical interference. In a normal PC, a bit flip usually results in a blue screen or silent data corruption. In a server, that could mean a database gets corrupted or a file is saved incorrectly.
And the great thing about ECC is that because it is a requirement for servers, the used market is flooded with it. When a big data center upgrades their servers, they dump thousands of sticks of DDR4 or even DDR5 ECC RAM.
Right, but there is a big caveat here. There are different types of ECC. You have unbuffered ECC, which some high-end consumer motherboards support, and then you have registered or buffered ECC, often called RDIM. Most consumer motherboards, even the ones that say they support ECC, will not work with registered memory. You need a server-grade motherboard for that.
So if Daniel finds a great deal on 128 gigabytes of RDMs, he cannot just pop them into his gaming rig.
Exactly. But if he is building a home lab with one of those used Xeon or EPYC boards we just talked about, registered ECC is the way to go. It is incredibly stable, and you can get massive amounts of it for very little money. We are talking about putting 512 gigabytes of RAM in a home server for a fraction of what 64 gigabytes of high-speed consumer RAM would cost. For things like ZFS file systems or running dozens of virtual machines, that is a total game changer.
I think that is a huge takeaway. If you are going the server route, the RAM is often the biggest win. Now, let us talk about storage. Enterprise SSDs. Daniel mentioned SAS versus SATA. Most people know SATA, but SAS, or Serial Attached SCSI, is a bit of a mystery to the average consumer.
SAS is fascinating. It is essentially the professional evolution of the old SCSI interface. Physically, a SAS drive looks almost like a SATA drive, but the connector is slightly different, so you cannot accidentally plug a SAS drive into a SATA port on your motherboard. However, you can plug a SATA drive into a SAS controller.
So it is backward compatible one way, but not the other. Why would someone want SAS at home?
Reliability and features. SAS is full duplex, meaning it can read and write at the same time. It also supports much longer cable lengths and has better error reporting. But the real gem in the enterprise SSD world is the endurance. Consumer SSDs are rated for a certain number of terabytes, written or TBW. A high-end consumer drive might be rated for 600 or 1200 terabytes. An enterprise drive, especially one designed for write-intensive workloads, might be rated for 20 or 30 petabytes.
30 petabytes? You could write to that drive every second of every day for years and not wear it out.
Exactly. And they have something called power loss protection. They have rows of capacitors on the board. If the power suddenly goes out, those capacitors provide just enough juice to flush the cache to the flash chips so you do not lose data. For a small business server or a home server running a database, that is huge.
So is it practical? Can Daniel just buy an enterprise SAS SSD and plug it in?
He will need a host bus adapter or HBA. It is a PCIe card that gives you SAS ports. You can find used LSI cards for $40 or $50. Once you have that, you can buy these high-endurance enterprise drives used. Even if they have been used in a data center for 5 years, they often have 90% of their life left because they were built for such insane workloads. It is one of the best ways to get rock-solid storage for a home server.
I have noticed that on the used market, you see these UI2 and UI3 drives as well. They look like thick 2.5-inch laptop drives, but they use the NVMe protocol.
Oh, I love U2. It is basically the best of both worlds. You get the speed of NVMe, but in a form factor that is designed for cooling and hot swapping. They are much beefier than the little M2 sticks we put in our laptops. If your motherboard has a U2 port, or if you get an adapter, those enterprise U2 drives are incredible. They stay cool because they have actual metal heat sinks as their casing, and again, they have that massive endurance and power loss protection.
Okay, so storage is a big yes, provided you have the right controller or adapter. Now, let us talk about the really fast stuff. Networking. Daniel mentioned 100 gigabit Ethernet. My brain still struggles with the fact that we are moving from 1 gigabit to 2.5 gigabit as a fast consumer standard, and the data center is playing with 100 or even 400 gigabit.
It is a different universe. To put it in perspective, 100 gigabit is 12.5 gigabytes per second. You could transfer an entire Blu-ray movie in about 2 seconds.
That is insane. But do you actually need that at home?
Honestly, almost certainly not. Even 10 gigabit is overkill for most people. But for a home labber or a small business doing video editing off a central server, 10 gigabit or the newer 25 gigabit standard is the sweet spot. And the used data center market has made 25 gigabit incredibly cheap lately. You can get a dual-port SFP28 card for $30 or $40.
SFP28 is the keyword there. Most consumers think of networking as an RJ45 jack, the classic Ethernet plug. But in the data center, it is all about those little pluggable modules.
Right. SFP Plus for 10 gigabit and SFP28 for 25 gigabit give you flexibility. You can plug in a module for fiber if you need to run a cable 100 meters, or a short copper cable if the devices are in the same rack. The cards themselves are very low power and very reliable. Moving to 10 or 25 gigabit at home makes things like backing up your computer feel instantaneous. It changes how you use your network. Instead of thinking, oh, I will wait until tonight to move these files, you just do it.
What about the 100 gigabit stuff Daniel mentioned? Or InfiniBand?
100 gigabit is where you start running into major hurdles at home. The switches are expensive, the cables are picky, and honestly, most consumer hardware cannot even feed a 100 gigabit pipe. You would need a massive array of NVMe drives just to keep up with the network speed. InfiniBand is even more specialized. It is used in high-performance computing clusters for incredibly low latency. Unless you are building a supercomputer in your basement to simulate the weather, InfiniBand is probably more headache than it is worth for a home user.
It sounds like there is a ladder of practicality here. 10 and 25 gigabit networking? Highly practical. Enterprise SSDs? Very practical if you care about data integrity. ECC RAM? Essential if you're building a server. But the multi-socket Xeon motherboards? That is where you really have to know what you are getting into.
You nailed it. It is about the why. If your why is just that it looks cool and was cheap, you might end up with a loud, hot, power-hungry beast that you regret. But if your why is that you need 80 PCI Express lanes for an AI project, or you need half a terabyte of RAM for virtualization, then that data center gear is the only way to do it on a budget.
I think we should talk about the small business angle too. If you're a small business owner, say a boutique creative agency or a small engineering firm, does it make sense to buy used data center gear instead of a new Dell or HP server?
That is a tricky one. For a business, time is money. A new server comes with a warranty and a 4-hour on-site repair contract. If your used eBay server dies at 2 in the morning, you are the one who has to fix it. However, if you are a tech-savvy small business, or if you have a managed service provider who knows what they are doing, you can build a much more powerful infrastructure for a fraction of the cost.
You could almost buy 2 of everything. Buy 2 used servers, set them up in a cluster for high availability, and you still spend less than 1 brand new high-end server.
That is exactly what a lot of smart small businesses do. They use the savings to build redundancy. If one server fails, the other one takes over. That is often a better strategy than having one expensive server that is a single point of failure. But again, it requires that internal expertise. You cannot just call a toll-free number and expect someone to ship you a replacement part for a 10-year-old Xeon board.
Let us touch on the environmental factor too. We talk a lot about e-waste on this show. There is something really satisfying about taking a piece of hardware that cost as much as a car and was destined for a shredder and giving it another 5 or 10 years of life.
I feel that deeply. These components are masterpieces of engineering. The quality of the capacitors, the thickness of the PCBs, the sheer amount of gold and rare earth metals in them, it is a crime to destroy them while they still have utility. A Xeon scalable processor from several years ago is still more than powerful enough to run a home media server, a firewall, a file server, and a home automation system all at once.
It is like buying a used industrial sewing machine or a professional-grade kitchen mixer. It might be old, it might be heavy, but it was built to run 24/7 under intense pressure.
That is a perfect analogy. You just have to be prepared for the fact that it does not have the creature comforts. It does not have a pretty BIOS with mouse support. It might take 5 minutes just to pass the post check when you turn it on. It is a tool, not a toy.
So, looking at Daniel's list, if he is just starting out, what is the gateway drug into data center hardware?
I would say a 10 gigabit SFP Plus network card and a used Enterprise U2 NVMe SSD. They are easy to integrate into a normal PC with a simple adapter. They do not add much noise or power heat, and you will immediately notice the difference in speed and reliability. It gives you a taste of that enterprise-grade feeling without requiring you to move into a house with a dedicated server room.
And from there, the rabbit hole goes deep. Next thing you know, you are looking at rack cabinets and wondering if you can vent the server heat into your greenhouse.
Don't give me any ideas, Corn. My tomatoes would love that extra warmth in the winter.
We have covered a lot of ground here, from the raw power of multi-socket Xeons to the silent reliability of ECC memory and the blistering speed of enterprise networking. It is a world of trade-offs, but for the right person, it is like being a kid in a candy store where all the candy is 80% off.
Just remember to check the power draw. I cannot stress that enough. Always look up the thermal design power of the processor and the idle power of the motherboard. Your future self and your electric bill will thank you.
Wise words from Herman Poppleberry. I think we have given Daniel plenty to chew on. If you are listening and you have a home lab setup that uses some of this big iron, we want to hear about it. What was your best bargain? What was the piece of gear you regretted the most?
Yeah, tell us about your loudest mistake. We have all had them.
You can get in touch with us through the contact form at myweirdprompts.com. We love hearing your stories and seeing photos of your setups, even if they are a bit of a cable nightmare.
Especially if they are a cable nightmare. It makes me feel better about my own desk.
And hey, if you have been enjoying the show and you find these deep dives into hardware helpful, we would really appreciate a quick review on your podcast app. Whether it is Spotify or Apple Podcasts, those ratings really help new listeners find us and help us keep the lights on, which is important when Herman is running his dual Xeon servers.
Hey, they are only on when I am testing something, mostly. Anyway, thank you for listening to My Weird Prompts. We will be back soon with more of your weird questions and our even weirder answers.
Thanks to Daniel for the prompt. We will see you all next time.
Goodbye, everyone. Stay curious.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.